We're on April 10th here. I do not have Quest 3 graded yet. I'll have it back to you Monday. Today we're going to talk about solving quadratic equations, and we're going to learn two methods for how to do that. So our first method is the square root property. Second method is going to be by factoring. So we'll start with the square root property. If I want to solve the equation x squared equals 16, I'm looking for numbers that when you square them, you make 16. So before we do any algebraic manipulation, can anybody think of a number that when you square it, you make 16? 4. What else? -4, right? Because -4 times -4 is also 16. Yeah. So this one we were able to solve in our heads, but we're going to learn the algebraic, what you write down to get to that answer. Okay. So we start with x squared equals 16. And the goal of all equation solving is to get the x by itself, right? Isolate the x. So, and you do that by undoing what's being done to x. So right now, x is being squared. How do you undo squaring something? You square root. So we're going to take the square root of both sides. And you end up with the square root of x squared equals the square root of 16, right? And then the square root of x squared is x, because the square root undoes the squaring. And the square root of 16 is 4, right? So it seems like what we did is legitimate, but we missed the solution x equals -4, right? We knew that was a solution going in, and it didn't come out, right? So the error occurred when we turned square root x squared into x, right? It turns out that the square root of x squared is actually the absolute value of x, and we saw that briefly earlier in the semester. All right, when the index is even, when you take the square root or the 4th root or the 6th root, you have to actually take the absolute value. So here's what the solution should have looked like. X squared equals 16, write square root of both sides. But then when you take the square root of x squared, you actually get the absolute value of x. The square root of 16 is 4. And then the final step is to try to think of numbers whose absolute value is 4. What numbers give an absolute value of 4? 4 and -4. Absolute value is just makes things positive, right? So the numbers whose absolute value are 4 would be 4 and -4. So this is the last step. Once you have the absolute value of x equals 4, then you get x equals positive or -4. All right, so taking the square root of both sides is a good technique if the equation has an x squared in it. It's got to have an x squared term. But it has to have no x term. It won't work if you have a term with just a plain old x, as opposed to an x squared. So for example, this guy, I could solve eventually by taking the square root of both sides, because there are no x terms. Every term is either has either x squared or is just a plain old number, right? This term has an x squared. This is a number. This is a number. This term has an x squared. Every term has to be either an x squared or a number. Right? But that would not work if I was trying to solve x squared equals 25x. Because at this point, if you square root both sides, you get the square root of x squared equals the square root of 25x. And this simplifies nicely, but the square root of x is even uglier than what you started with. Right? It doesn't help at all. It doesn't get rid of the x's. So we'll try to do that kind later. But for now, let's solve this 7x squared minus 1 equals 199 plus 3x squared. So first, you want to isolate the x squared. Gather all the x squareds on one side and all the non-x squared terms on the other. So start by what? Subtract 3 what's? 3x squareds. Yeah. So I'm going to subtract 3x squareds from both sides. And I'm going to get 4x squared plus 1 equals 199. Then what should I do?
Subtract 1.
Oh, sorry, I wrote plus and it's supposed to be minus. Add 1 to both sides, right? So I have 4x squared equals 200. Then what? You don't square root until you have the x squared all by itself. So I'm going to divide by 4. Yep. So I have x squared equals 50, and then, Oatmeal, square root. So I have the square root of x squared equals the square root of 50, which means that the absolute value of x, right, the square root of x squared is the absolute value of x. What's the square root of 50? Nice. You've done it so many times you can do it in your head now? Yeah. So Oatmeal recognized 50 as 25 times 2. So he rewrote this as 25 times 2 and got, when you take the square root of 25, it comes out of the radical and becomes a 5. So that's 5 square roots of 2. But that's the absolute value of x. So that means that x can be plus or minus 5 square roots of 2. And that's written much neater in your packet than my writing on the board here. All right, so that's our square rooting method. And now we're going to change gears, solve a much broader class of quadratic equations. A quadratic equation is just anything that can be written in that form. It's got to have an x squared term, an x term, and a constant term. Okay. Now, a, b, or c, any of them could all be 0, except for a. If a is 0, then it's not quadratic. Then it's just a line. All right, so it turns out that this standard form is pretty useful. So we want to get one side of the quadratic equal to 0. That's usually a good first step. So I'm going to solve x squared minus 24 equals 5x. I would like one side to be 0. So what should my first step be? Subtract 5x. Okay. So I'm going to have x squared minus 5x minus 24 equals 0. And I put the 5x in the middle. I can put it anywhere I want, but I like it there because I like it to go x squared x constant. All right, then I want to factor the left-hand side, right? So we've been working on factoring a lot lately. So I want to factor x squared minus 5x minus 24. So we could do the double bubble, right? It could be that you don't need the boxes anymore and you can just factor this. Anybody can do it in their head?
Yep.
What do you got?
X minus 6, x plus 4.
Okay, so that, let's just check. If I multiply this out, x times x is x squared. 8 and 3. You did the check faster than I did. X minus 8, x plus 3. Yep, and the way you pick the 8 and the 3 is you say, okay, 8 and 3 multiply to 24, negative 8 and positive 3 multiply to negative 24. But when you add them together, negative 8 and 3 make negative 5. All right, so before I finish solving this, let's just also solve that, do that factoring with the box. Just for those of you who like the box. All right, so we put the x squared in the upper left, and we put the constant term in the lower right. And then over to the side, we write negative 24x squared, and we list its factors. What are things you can multiply together to make negative 24x squared? 6 and 4. 6 and 4, one of them has to be negative. Negative 8, positive 3, 8, negative 3. And these should all have x's, sorry. Yep. All right, and we are looking for a set of factors that adds up to the middle term here, the negative 5x. So that would be your negative 8x and your 3x. They add to negative 5x. Okay, so then I put in negative 8x and 3x, and it doesn't matter where I put them. Either box is fine. Then we look at the first row, and you factor out the greatest common factor. What's the GCF of this first row? X, yep. X times what gives you x squared? X times what gives you negative 8x? And x times what gives you 3x? X plus 3, x minus 8. So that's our factoring. So we just rewrote this quadratic as a product, right? And I love doing that when I have 0 on the right-hand side, because let's just pretend I'm giving you a riddle and I say, I'm thinking of two numbers. When you multiply them together, the answer is 0. What has to be true? What has to be true of one of the numbers? One of the numbers has to be 0. If you multiply two things together and the answer is 0, the only way that can happen is if one or both of your things, of your factors, are 0, right? So either it must be that x minus 8 equals 0, and or x plus 3 equals 0. Right? Then you just solve each of these and we get x equals 8, x equals negative 3. Those are your two solutions. Two numbers that will make that original equation true. No, because if x minus 8 equals 0, then you do plus 8, add 8 to both sides, right? And you end up with x equals 8. Here I had to subtract 3 from both sides, so x equals negative 3. All right, any questions? All right, let's get started on the activities then.